Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh and I will be your moderator for today's event. And goodness gracious, folks, we have a real treat for you today. I'm very pleased to announce that we have none other than Big Blue. IBM indeed is in the briefing room today, and the topic is about as exciting a topic as we are going to have on this show. The specific title is A Futuristic Reality, the Big Data Platform. The briefing room with Krish Krishnan and IBM. So let me jump right in here. There's a slide about yours truly and enough about me. So as many of you know now, the topic of the briefing room, or the mission, I should say, of the briefing room is really to reveal the essential characteristics of enterprise software. And so what we do is we take a much different approach than just about any other webcast you'll see in the industry. You are going to experience here a live analyst briefing. So typically in these webcasts, an analyst will go first, talk for 20 to 40 minutes, then the vendor will come in after that and do sort of a product pitch of how that ties into the topic at hand. We turn that around in the briefing room. So I do the value proposition stuff up front. I then hand it over to an innovative vendor who goes for about 20 minutes and talks about the technology, what they've built, why they built it a certain way, how it works, where it fits into an information architecture or an application architecture. And then the analyst, who has a week to review the vendor slides, gives a brief response for about 5 minutes. So one of the big differences here is the analyst and vendor do not coordinate before the show. And the reason we do it that way is because we want to expose the kind of organic conversation that occurs when an analyst who focuses on a particular space talks to a vendor and gets a briefing from them. So the idea is that if they coordinated too much, well, then all the good questions would have been used up in the pre-call, and we don't want that. So we want to capture the magic. And I can tell you it was really inspired by me watching my partner a couple of years ago take a briefing at a conference, and I was very impressed at how Dr. Robin Bloor, my partner, was able to get right to the heart of a particular matter and bring out this very productive conversation. So we cover a different topic every month in the briefing room. We always broadcast on Tuesdays at 4 Eastern. And the reason we do different topics every month is largely so that you as an audience can get good apples-to-apples comparisons of technologies within particular domains. So once in a while we'll have sort of a catch-all category that's not so clean-cut, like this month, which is disruption. So we're talking about disruptive technologies in the field of information management. And this topic of big data is truly disruptive. I mean, I have never seen a topic rise so quickly and become so prominent in this industry as with this whole concept of big data. And of course, it's a term that refers to a whole variety of different things going on, and we have to remember that there is a real confluence of technological innovation that is coming together to bring about these changes. Processor speeds are much faster, storage is becoming much cheaper, we're starting to see solid-state drives become much less expensive, and as we learned last week in the briefing room with Grid Game, reading from memory can be thousands of times faster than reading from disk, even tens of thousands of times faster. And so as the price of SSD, solid-state drives, comes down, well, that fundamentally changes the way you can do business. And there are other huge changes going on. Streaming technology. I've heard from a whole variety of vendors that are now getting into streaming technology, and some vendors where I'm thinking, really? You guys are doing a stream now? Well, that's a straw in the wind. That's because things are changing. And I see this whole big data platform concept, while still relatively nascent, as really a fundamental shift in the manner in which companies can access, harness, and use data and use the insights gleaned from data. So it's a very interesting topic. And keep in mind, too, we have all of these NoSQL database engines coming out, which are really designed to circumvent many of the constraints that were intrinsic to the relational database model. So you've got social changing, mobile changes, you've got changes in the way that information architectures are designed, and I would argue that this whole movement in big data and big data platforms and big data analytics is the force majeure, if you will, that is fundamentally altering the way that people do business in this industry. So that's what we're talking about when we talk about disruptive change in the field of information management. Our analyst today is Krish Krishnan. He is a really smart guy, folks. We're very pleased to have him online today. He's a very innovative thinker. He thinks outside the box, and he keeps his eyes on what's going on out there in the real world. And, of course, we've got IBM. Goodness gracious, the InfoSphere platform, a full suite of big data analytics solutions and appliances. We're going to learn about big insights. We're going to learn about streams. We're going to learn about a lot of stuff. And you see a quote from my good friend Merv Adrian here: stream-based computing will change the world, and the power of IBM's engine will be a big accelerator of that change. So we're very pleased to have Anjul Bhambhri here. She's calling in from Silicon Valley. She is Vice President of Big Data at IBM. And Anjul, I'm going to go ahead and push your first slide, then I'm going to hand the keys over to you, and you should get this in just a moment. Let me know if you don't. So if you would, just click anywhere on that slide and use the down arrow of your keyboard to move the slides. And Anjul, the floor is yours.
Thank you. Thanks. It's a great pleasure to be here and have this discussion around all of our, I guess, favorite topic, big data. I'm trying to just make sure that we can move the slides here.
There you go.
Okay. Yep. So I think this is not new news to anybody that there is a huge deluge of data that we are dealing with, data coming from sources like social media, data coming from a large number of machine-generated sensors and mobile devices, RFID tags, etc. So at least I don't think there's any debate that there's the volume of data that we are seeing now we have never seen before, and there is a wealth of information hiding in this data which needs to be leveraged for better business outcomes. So if we look at what are we really seeing, like you were mentioning, Eric, that in terms of the growth of the data, combining that with what we are seeing from the standpoint of hardware costs and storage costs go down, this has definitely led to a new era of computing, I would say, for enterprise business intelligence. And this requires businesses to process and analyze information from everywhere, not just the traditional sources that we were used to before. So this really requires a great deal of flexibility to deal with data that's noisy, that's sparse, less structured, and in some sense constantly changing. Even the sources, data sources that businesses need to use or leverage today versus what they were doing, even a few months ago is changing. So they need a way that they can leverage these new data sources, and at the same time, there'll be other data sources that will be coming, which will be useful or which they may deem useful, and so their data platform has to be extensible that they can incorporate these new sources of data. So in terms of, dealing with the sparse, less structured, noisy, constantly changing data, the other aspect of this is there's extreme scalability required because, a lot of these applications or these new classes of applications that we are seeing, they require the ability to sometimes maybe store everything and to process everything at extremely low latency. Now, not all the times the information has to be stored, like you were mentioning that, there are stream computing capabilities, so some information is never persisted. It's just analyzed, processed, and actions are taken without ever having to persist that data. But nevertheless, there are lots of applications where the key is to be able to process and analyze all of the data at extremely low latency and not a subset of the data. So which is really giving, birth to new classes of analytic applications. And in that context, when we look at these new classes of applications, this required new technology, which is not to say that, everything that we've had to handle data goes away or all that technology is not useful anymore. But there's definitely new technology that needed to be brought in the enterprise or that, to really leverage the big data. And we believe that this requires sort of like what we are calling as the big data platform approach. So what do we mean by the big data platform? So when we talk about the big data platform, this is really a platform that can be integrated within the existing enterprise information architecture and the existing business processes easily and in a cost-effective manner, with a goal of that businesses, as they discover new insights, they can modify or reform their business processes. So traditional applications and capabilities alone, just by themselves, would or could prove at times limiting. They may prove to be not cost-effective when enterprises are dealing with these large volume and variety of data and the speed at which this data is coming. So if you look at the right-hand side, the bullet points on the right side are what we consider as, at a very high level, the characteristics of the big data platform. That is, ability to really store and process data, both in the MapReduce or NoSQL paradigm, as well as combining that with the MPP data warehouse environments. So that integration and that ability to do both is pretty important. And at the same time, be able to process streaming data as it comes in. And it's obviously not enough to just ingest and acquire all this data. The key here is to be able to perform advanced analytics, including things like machine learning, text analytics, closer to the data. And to do all of this, a development environment is needed so that new applications can be built, debugged, deployed. And at the same time, as data is being integrated from all over the enterprise, it's important to preserve the security and privacy policies that have been implemented, because big data doesn't mean that those security and privacy policies are not important. In fact, they get more critical given the kinds of information that can be available and gleaned from this data. So, and when we look at the use cases across the enterprise, a lot of times I've heard people say that, big data is just a technology push. And I would say that it's not just a technology push paradigm. Because, the range of applications, the business applications and the use cases for big data, they are spanning the entire enterprise. In fact, I think I was seeing a recent quote that, a lot of the buying decisions for technologies are going to be not just be made by the IT departments. It'll be the chief marketing officers in the enterprises that are going to be influencing the decisions to acquire the technology or which technology to acquire based on the kind of insights, based on the kind of, the challenges that they have to overcome to grow the bottom line. So this slide just gives you a quick overview of the sort of the main applications for which customers are leveraging big data, be it Hadoop, be it streams, be it, how to combine it with the information that might be already in warehouses, And these are substantial business applications, really spanning the range from customer-facing back office that provide a lot of value. And all of these would not be possible or game-changing if they were not powered by the infrastructure and applications that really allow you to aggregate, mine, and leverage big data. So in that context, let's look at a few of these applications. So Vestas is a company in the energy and utilities space, and it's a company based out of Denmark. And their goal was really to place wind turbines in locations, in optimal locations for maximum power generation and lower the maintenance costs. So for this, they need accurate knowledge of how the wind will behave at various locations over multiple seasons, and they needed to build interactive applications for business users as well as planners to discover those optimal locations. From the standpoint of what data do they leverage, there's a lot of publicly available weather data, but the granularity of that data is not sufficient for the level of accuracy that they needed. So they have built simulation algorithms to induce huge amount of data sets in granularity, which is closer to like 10 meter by 10 meter radius, based on publicly available weather data. So before they came to IBM, it would take them about 3 weeks to respond to a customer's request about placement of the wind turbine. And they ran these simulations to predict that location on a very small subset of all the data that was available to them. When you talk to them, they say that their data library, it has so much data that if you were to watch it on high-definition TV, it would take you 70 years to watch all of that weather data. And they were using, and all of this data in their case is structured and semi-structured. So we are not talking about unstructured data here at all. And they were using a warehousing approach, and they were building these models, leveraging a subset of the attributes and a subset of the data. Now with IBM's offering, specifically in this case, Big Insights, they are running simulations on about 2.5 petabytes of data, and this is expected to grow to about 10 petabytes in 3 years. And they're running it at all possible locations and have built an interactive application for their business users and planners to really discover those optimal locations. And it used to take them about 3 weeks to respond to that customer request, and that has changed to the response of a mouse click at this point. And if there was, there's just talking very quickly about what is the architecture here. The first step here was to really run the simulation algorithms. In this case, these were R scripts. And these were run at scale using the MapReduce framework. And Big Insights has a very high-level scripting interface called Jackal, which embeds R modules, and we can execute them in Java and MapReduce. And the output of these simulations was stored in an optimized column store to enable fast response time for the kind of queries that they need to run. And in the process of running the simulations, there were a large number of small jobs which needed an optimization to dynamically combine these large amount of small input files to lower the overhead of MapReduce tasks. MapReduce tasks, in general, they work well for large jobs with long-running jobs with large amount of data. But when it's a lot of small jobs with small amount of data, the performance is not optimal. So we've made enhancements to MapReduce so that it has a broader appeal for a broader set of use cases. And then Vestas built a custom application that allows their end users to interactively query the optimal locations for the placement of these wind turbines. So I just wanted to, I thought I'd spend a little more details on this to give an idea of the technology. Now, if we look at, the next use case here is what we did with Cisco. So in the previous example, we looked at, structured, semi-structured data. In this case, Cisco is leveraging multiple, actually, big data capabilities for various use cases. One of them is to develop an intelligent infrastructure management solution. And big data is a key enabler for Cisco's new Smart Connected Buildings initiative. And this is in a pilot form in, I believe, a number of companies worldwide, including Asia Pacific. And the objective here is to really leverage machine learning and predictive modeling to optimize energy consumptions and monitor and control of equipment like ACs, fans, lights, etc. So the key requirement here was, in Cisco's case, ability to ingest huge amount of log data, again, several petabytes, which is generated by IP-connected devices and sensors, and then run predictive analysis to determine the optimal building energy settings and prevent software and hardware failures. So again, the challenges here were the volume and the speed at which the log is generated. They mentioned that they generate about 200 to 300 terabytes of log data every year. Most of the log data is semi-structured, but the failure trace log data is mostly unstructured. So here we are dealing with semi-structured and unstructured data. And then, of course, the predictive model is, that needed to be built was to determine the pattern or the signature of common problems. And using our streams capabilities, they then implemented a real-time monitoring system that was needed to detect patterns and generate alerts in real time. So one of the kinds of use cases that you would see in these different industries is that they are improving their, maybe, it could be, models which are related to, depending on what industry they are in. It could be fraud detection, it could be customer churn. And those are done using maybe a Hadoop-based, like a Big Insights product, or they may have already done it using their warehouse. And then those models can be scored in real time using streams capabilities as very large volumes and variety of data comes in. So this gives them that extremely helps businesses meet the extremely low latency requirements, which are inherently, cannot be met just by a Hadoop-based system. And may be difficult to meet just using the warehouse system. So streams really helps facilitate that. Just one more use case here is around the city of Dublin, and big data is the underpinning of many of the Smarter Planet initiatives and success stories that you can read about from IBM. So very quickly here, this was, with the city of Dublin, we've implemented an intelligent transportation system, which is designed to provide updated speed and traffic flow measurements and travel time estimates and statistical aggregations of current traffic estimates and statistical aggregations of traffic conditions in real time. So it's built on IBM's big data platform using InfoSphere streams. And at this point, it provides the city of Dublin, capabilities to visualize in real time and be able to predict the arrival times of about 1,000 of their buses on 150 routes and 5,000 stops daily. And this has enabled them to optimize bus routes, stop locations, and they're using, GPS positions of every bus and analyzing it. So this is just a slightly different use case here. Moving on, this is an Asian telecommunication provider, and this is they were using a warehouse and ETL before for processing call data records, but the volume of call data and IPDRs the growth has been phenomenal. And so again here the case was that analyze these large volumes and be able to predict and stop customer churn and resolve billing disputes. So again, you can see the benefits that the big data platform capabilities have provided here. No big data, I guess, presentation is complete without talking about the social data. So this is another very interesting use case in the area of sentiment analysis for products and services. This is work that we're doing with an entertainment company, and they wanted to find out the effectiveness of movie trailers. So analyzing blogs, tweets, and so data that you see on the left-hand side was the data that was ingested in Big Insights. We use text analytics capabilities to extract information and be able to analyze them and show the results from an intention and sentiment standpoint. What you see on the right-hand side is some of the information that we were able to extract and provide. And the end result is that we were not only just able to deliver the overall sentiment about the upcoming movies, but we were able to deliver the reasoning for the sentiment. Like, for example, people don't like, say, the sequences of scenes for the trailer, but they may like the background music, and certain age and gender group like specific actors or actresses, etc. So this is these are some of the use cases. There are many more, but in the interest of time, I'll move to what is the IBM's big data platform that is enabling all these kinds of use cases, and what we are seeing is that most of the big data projects are often the implementations that combine the use of multiple technologies, and it's not just one technology. So here is a common approach that we are seeing, that data, which is both structured and unstructured, is loaded into the big data environment. Information extraction capabilities are used to extract and annotate the information, especially if it's free text. And then deep analytics can be run inside the MPP appliance or a NoSQL cluster. And these analytics include statistical analysis, data mining, predictive modeling. These could be sentiment and intention analysis or spatial time series. And the analysis obviously includes rules and predictive models, and these can be applied to real-time stream data. Ad hoc experimentation and visualization tools are also used by business users to really fine-tune the analysis. So one part of the IBM's big data platform is based on top of Apache Hadoop. This is just one of the components. It's called InfoSphere Big Insights. And it can help organizations in a very cost-effective manner analyze petabytes of structured, semi-structured, unstructured data. It enhances Hadoop with performance, like we had talked about in an earlier case where investors. It's called adaptive MapReduce. It enhances Hadoop from a reliability, security standpoint. Lots of administrative features for performance monitoring, tuning have been added. There's sophisticated text analytics capabilities, and there are tools for data exploration and visualization. One of those tools is called Big Sheets. because of the inherent nature of Hadoop, which is really more suitable for batch-oriented jobs, stream computing is another core capability. It supports ultra-low latency on diverse data types. And again, there could be structured, semi-structured, unstructured data that could be fed in. It could be processed in real time. Patterns can be observed, analyzed, and actions can be taken based on those patterns. Another core component is really the data warehousing, be it IBM, the Netezza, or InfoSphere Warehouse. Netezza delivers deep insights using advanced analytics in generally sub-seconds or minutes and on very large petabytes of relational data. And same thing for IBM InfoSphere Warehouse. It supports operational analytics and applications with really up-to-the-minute insights. And of course, all of this, like I had said earlier, was that we are not sacrificing the security and privacy policies. So it's important to obviously preserve and deliver all of this information in a trusted manner. So now that we've seen the platform, there's no SQL, there's streaming, there's MPP warehousing capabilities. There's a lot of focus that we have on improving the time to value and productivity. And two important areas there are accelerators and application development and end-user visualization tools. As you know, we've done a recent acquisition of a company called Vivisimo. The primary reason for this is that, as I was mentioning earlier, that enterprises really want to leverage data which is not just in a Hadoop file system or not just in a warehouse, but it could be in CRM systems, it could be in SAP applications. So Vivisimo really is bringing to the picture that, we can really federate and discover and explore data which may reside anywhere without having to move that data around. And here what you can see is that, and with a very nice front end, so that, the results of all these queries can be brought together, and it becomes appealing to the business user that they can really get all the information in the right context available to them. So this is just an example of a financial investment advisor, where he can see the important clients, investment products that he's working with, and more new insights. He can see the sentiment changes from the major clients and roll up the sentiment view for major products. Accelerators are building blocks for the kinds of use cases that we talked about, so that as customers are building these, they don't have to start from scratch, but they can leverage our building blocks that we are providing, be it to handle telco data like CDRs and IPDRs. It could be for handling social data, for log data. So our strategy is to build accelerators across multiple engines, which could be built across Hadoop, MapReduce, streams, warehouses, and they include analytics engines. They include pre-built rules, models, visualization capabilities that are pertinent to those use cases. And these could be horizontal applications like social media analytics or data mining, or they could be industry specific. And obviously, we are our platform is very open and extensible. So we are very actively building a strong ecosystem around this platform. So while we are providing a lot of the technology, we have over 100 big data business partners already signed, and their applications are running on top of our big data platform. So this way the customers, right, are not locked into any one technology or any one stack. They can always go with what IBM has, but they can also run partner applications on top of our platform. And this topic is a very, we can go on and on, but there's more material that you can, look at our Big Data University. We have a YouTube channel on big data, and a lot of these case studies are available on the web. So hopefully this gave you, an idea of what IBM is doing in this space. Thank you.
Well, that's a really, really good comprehensive presentation, and you cranked it out in record speed. So not only are the systems fast, but you are too. Let's bring in Krish Krishnan now. Krish, I just handed you the keys to the WebEx car. So if you would just click anywhere on that slide and use the down arrow on your keyboard to go. And folks, we have a ton of great questions. Thank you so much for sending those in. We'll be sure to get to just as many of them as possible. And we may even go a bit long here today. So stand by. Krish, the floor is yours.
Thanks, Eric. Anjul, that was a fantastic set of opening remarks about big data and the platform. So I'm just taking a quick recap of what you outlined in terms of data that's available to an enterprise, right? There's all kinds of data that business analysts and SMEs want within the enterprise to be able to visualize not only their behavior and in the eyes of their customer, like you outlined in sentiment analytics, but it is more in terms of the whole innovation that the industry is going through, where organizations are wanting to become more services-oriented and customer-centric as opposed to being product-oriented. To give a slant on what Anjul just presented in terms of the platform, the big data platform also has a twist in the tail. With big data, everything evolves every second as we speak. I mean, in the last hour that we've been talking, I'm pretty sure there are some announcements that are coming out on new things. So if you take a quick look and a recap at the data that a corporation has access to, you can actually categorize the data into multiple blocks. And you all have a copy of this presentation, so you can visualize this later at your own leisurely reading pace. But if you are now going to start a big data project with all that data and you're going to use your traditional tools, obviously, you're going to be lost in wilderness. And that is the whole premise of this briefing with IBM, is to understand what Big Insights is bringing as a comprehensive platform. So obviously, it comes with a lot of tools. It comes with a lot of different instructions in forms of accelerators and data models. And together with it, it also comes with a number of connectors, obviously, as Anjul has explained, and I have a few questions lined up to ask her, which will generate us appropriate outputs. Now, the way I look at big data is a little different from the way the rest of the industry looks at big data. To me, big data brings workload, and what workload is basically is the way, CPU, memory, disk, and all the other system resources are utilized by a given task. I mean, the task may be, an application running a simple query. It could be a large batch job. It could be a micro batch job. It could be streams processing. It could be any kind of interaction that's happening from a data perspective, from an acquisition to a consumption layer. Now, if you look at the broad brush classification, we've bucketed, data that we could actually get our hands on and structure and actually manage within traditional applications into one bucket, and then we've bucketed all the new kinds of data and other systems data into another bucket, and we have the whole EDW sitting outside of all of this. The issue here is that since you're putting so much of pressure on existing systems, you're going to actually end up having a lot more risk and a lot more failure if you're trying to attempt, to look at big data in this perspective. Instead of which, if you look at big data and say, I'm now going to actually take a platform-specific approach, I'm going to have to build a heterogeneous ecosystem which is going to involve a bunch of technologies that I need to integrate. And the integration is the key here, because that is where data governance, metadata, and master data management come into play when you want to bring in big data, unstructured, semi-structured, real-time, streams, social media, you name data of any kind across the corporation. as you start bringing in these different facets of data and look at how to process them, you're going to bring in non-traditional sources, you're going to bring in non-traditional formats at non-traditional speeds unheard of before. Hence, you're going to adopt unorthodox techniques to process this data. So you wouldn't design your classic data model before and then put the data in. Obviously, you're going to get the data, you're going to do discovery, and then you're going to create a data model for it. And hence, the need to isolate workload and be able to actually leverage all the different kinds of technologies available harnessed into one platform. So that was the vision that we were briefed by IBM here. So I have a few questions, Anjul, that I would like to actually open the floor with, and then, once we go through our banter of the list of questions I have, I think I'm turning this over to Eric, and then we go through the questions that the audience has. One of the interesting observations I got from the Big Insights discussion, Anjul, is that in the last 6 months, there is a lot of update that has happened in the platform. I mean, my prior briefing happened 6 months ago on this platform, and there is a lot of changes that have come through. And I think the most significant one that you pointed out, or the significant two that I can remember right now, is the whole Vivisimo integration. And then the other piece that really caught my attention, and I think this is something that I want to understand a little more better from your perspective, is the whole nuance of the accelerators, right? With big data, most of the programs, right, whether it's a POC or whether it is a real customer engagement, either which way, the customer has no idea what the data is, what the format is, or what to expect. I mean, often people start with a set of requirements, but then the requirement keeps expanding. I mean, the scope creep here is an acceptable variable, because you really don't know what you're getting into until you look at the data. Would these accelerators create a roadmap, or help create a roadmap for an organization in such a way that they could ingest all the data depending on the kind of accelerator interfaces you provide, and then once they have the analytics as the output, would they be able to say, aha, I'm missing these 3 additional variables I need to get this metric completed with, so let me go and just bring in those 3 additional variables. Is that the goal of the accelerator, holistically, or what is the exact goal behind these accelerators?
So it's a very, very good question, Krish, and obviously there are lots of questions in this one question. So from the standpoint of like why you're absolutely right that when I think not just IBM, when everyone started, right, we were the thinking was big data equals Hadoop, but I think very quickly, not just vendors like ourselves, but also the customers started realizing that, while Hadoop is one and it's an important component of big data, but it is not, that's not the end of the road here. That's just, helps you start the journey, but there is more that is needed for our clients to be solving their challenges, right? Because that was more like a technology that was now available, and it found a good problem, which was big data. But the problem still remained. And from to that end, what we started doing was, as we worked with almost close to 200 customers now, in the space where we are just using, say, big insights and streams, and like you were saying that it's hard for them to get started just with the technology. So they needed, especially as they are dealing with data, whether it be text, whether it be video, audio, in its native format. How do you ingest this data? What kind of analytics are needed on this data? When you have to extract information out of this data, how do you define those rules to extract information out of it? As you're building, say, models to model, say, your customer behavior or your customer sentiment or, customer churn, what kinds of attributes should be considered in building those models? Because, building the model itself is a huge task in this whole big data exercise, right?
Yep.
And it's an iterative process. While, people love to see that, we are able to now predict customer churn better or predict fraud detection better or understand the customer sentiment behavior better. But there is a lot of hard work that happens to make that happen in terms of how to model this. A lot of models have to be thrown away before, we come up with the right model. Sometimes you have to use a combination of maybe multiple models. There's no one model that fits. So what we are doing with accelerators is really providing a combination of these things out of the box, not for all the use cases, but it's like you were saying, there's a roadmap. We have done it. We'll be in our release later this year. Right now we have these in beta testing. We will be shipping accelerators to analyze log data. We'll be shipping accelerators to analyze social data. We already have actually in production in various telco accounts the telco data accelerator to analyze call data records, IPDRs. And these accelerators have been built by harvesting, the assets that were used in customer engagements and where we have seen that, so that we don't want everybody to be starting from ground zero.
Yep.
And it also, a lot of these accelerators also come with their own visualization tools which are pertinent to that kind of data. While out of the box we ship something like, a spreadsheet kind of an interface which can be used, but say log data may require certain different visualizers so that it's the insights can be caught and gleaned faster. So some of these are specialized visualizers just for that particular kind of data.
Wonderful. Now, so that definitely answered a number of different things, right? So I'm going to paste this and get to a different question here. In the roadmap for big insights in the next 6 months, right? Understandably, the ground is moving under our feet as we are standing on it and building these platforms. What would you think should be, any of your partners, interface point with big insights? So, for example, you outlined, over 200 registered partners that you have that are working with you on the platform. So do any of these partners have a fixed roadmap that aligns with your roadmap? And is there a vision that you can share in terms of release cycles for this so that the customer community is going to be a lot more educated? In a 5-minute or less, if you will.
The partners that you're seeing in this space are, some of them are to do with the tooling space, right? Like KarmaSphere, DataMirror,
Yep.
They're all our partners. And they are certifying on the new releases of Big Insights as it is coming out. And we are obviously also sharing with them, the capabilities that are unique to IBM's big data platform. So, beyond sort of Hadoop. And of course, we are encouraging them to leverage those capabilities because those capabilities are being leveraged by our customers in their use cases. And then, of course, there is all major system integrators, regional system integrators, who are building their big data practices around IBM's big data platform because, services is a big part of, how some of our customers would want to get started. So they can leverage, of course, IBM's services organization, but if they wanted to go to their favorite system integrator or an RSI, then they will find that, we have trained a lot of them on our on our platform capabilities. And every time we have a new release coming out, we spend a lot of time in educating and enabling our all of these system integrators. Then, of course, there are specialized applications around sentiment analysis and understanding customer behavior, product sentiment, and marketing campaign. How those are doing. So there are a lot of I think there are like about 400 startups in the Bay Area itself. And so we are working with a lot of them so that they can leverage IBM's unique capabilities so that what they deliver as applications or solutions to their customers, they are able to give those customers a competitive edge. And pretty much our support to all of them is that as new releases come out, we want them to certify against our latest and greatest. And to that end, we have a dedicated set of a team that works with these business partners so that, it's not just them doing all the work. We help make that happen such that it's available at our release boundaries.
Okay. One other question before I would turn this to Eric, and this is going to be if you will, maybe a touchy one, so it's up to you in terms of how you would want to answer it. As opposed to the competition, right? I mean, that's out there. What would you attribute to be the reasons for the success of a Big Insights platform? I mean, understandably that the platform is nascent and the adoption is definitely evolving, right? I mean, I wouldn't think that neither IBM nor anybody in the analyst community is saying that Big Insights is a very mature platform and there is X number of things going on. But obviously, considering the competition that's out there, either the open source community itself or the other vendor communities or your other tier 1 competitors, how would you position the success of Big Insights?
So, we are obviously seeing a lot of customer interest, across the board in every industry vertical. Some are evaluating and adopting the technologies, but there are customers that are in the forefront, and we have customers that are already in production and are reference customers. So we are seeing that, having a Hadoop-based platform is only part of the picture. For enterprise-wide adoption, the breadth of the platform capabilities, especially in terms of handling diverse workloads and in-place analytics is very, very important. And integration with the rest of the enterprise systems is if that integration doesn't exist, that can be a showstopper in some very large customer accounts. And and also this integration has to be done while we preserve and adhere to the security policies of those existing repositories where the data might be residing. So while obviously bringing in new data sources, which is what IBM's Big Data Platform allows them to do, it's important that, as we are pulling and, federating and discovering and querying their existing repositories, we are following those security policies and preventing and protecting unauthorized access to any or all of this data. And what is really causing this thing to move, I would say, at a rampant speed is that we can analyze a very wide variety of data and pull this information in context, right, which is what was demonstrated by, like, Watson, right? Be able to answer the question in context at a very fast speed. And I think, that is a lot of our building, what you see in Big Insights and Streams and our Netezza appliance, these were building blocks for Watson. So so I think that is a very very important sort of a use case and a showcase for us, which demonstrated that we can pull information, pull it in the right context, stitch it together, and deliver it at an extremely low latency. And what we are doing this, Krish, is what is making this more successful is that we can deliver this to a non-IT user. I mean, that is our big focus even moving forward, right? Because if the insights from big data cannot be gleaned by a non-IT user, then this movement is going to fail. So I think that is very key, and that's something about which we are very excited by our latest acquisition of Vivisimo, because that gives us a big leap in that direction of delivering the insights to a non-IT user.
Absolutely. I mean, I can't concur more on that point. I mean, the whole success for big data lies in, the realization of insights, by the community. So in the interest of time, Eric, I think I would turn the floor back to you, and we'll take some audience questions.
Absolutely. Thank you very much, Krish. We do have a ton of awesome questions here. So, Anjul, what I'll do is I'll just start at the top. We'll do it like it's a call center. First questions come first. So let's see. Right at the top of the show, we had a great question. Let's see. So one of the attendees asks, is the big data movement, or is the big data management problem spurring the development of better silo database integration across and between enterprises?
So the big data is actually, breaking the silo, right? Because if this creates yet another silo, then it's not.
Problem.
Yeah, then it's a problem. So the quick answer would be it's breaking the silos, and how that is being done. We can certainly, I don't know, Eric, if you have the list, the email addresses of people, I would be happy to respond to them individually or point them to links or papers which talk about how we are breaking the silos. But the proof point of that is that all these use cases that I took all of us through was there was, in all of these cases there's a warehouse in the play, and then there was in the new data or the new ad hoc kind of analytics were being done using a Hadoop-based offering, which in our case is Big Insights. And we do see a lot of people that they have built their predictive models by with a lot of data that they've always had in the warehouses, but now they want to score it in real time, so they're deploying it in streams. So so all of this is around integration and not around silos.
And you mentioned Hadoop. Does IBM have its own distribution, or should people use the Apache distribution? How does that work?
So IBM Big Insights ships the Apache Hadoop distribution.
Okay.
But we also support, we are really not in the distribution business. So we also support like Cloudera 3.0 distribution. So all the capabilities that I talked about, which are above and surrounding Hadoop, are also all available on the Cloudera distribution. And we released on 15th of June, we released InfoSphere Big Insights, which supports CDH 3.0.
Okay, good. And I'm just going to start hammering through all these questions, and if you run out of time, just let me know. Here's a really good question. One of the attendees asks, how does this solution distinguish the high-value data from the low-value data? This is a typical challenge in big data applications.
So I think that it the insights are, I think it's certainly what I would consider as getting high value out of, if you don't gain those insights, then, this could just become low-value data. So the fact that we can get value from all of the data makes it that this is high-value data, right? Because if you couldn't glean value from all of the data, if you can only do it from one or the other, then it's low-value data.
Okay, good. Let's see. Let me jump right into another one here. Okay, here's a good question. In the solutions that you described, one attendee asks, how often did the clients use the full data set as opposed to a subset thereof? And specifically for real-time analytics, how often do you need to query the full data set, if ever?
I guess it depends, right? A lot of the clients start with still a subset of the data, right? And then if they feel that, okay, now the kind of insights that they are getting, this is like I guess when the client becomes greedy, right? Then they want to add more to it, and I guess human nature, there is a greed angle to human nature. So if they have data available, they keep adding it. And I think the ROI that they have seen is that they are getting more and more and newer insights. So I think that is what kind of motivates them to keep adding. In most of these the use cases that I shared here, people started with a subset of the data, right? Like if they had 10 petabytes, they started with 300 terabytes, then moved to about 2 petabytes, and now over the next 3 years they want to move to about 10 petabytes. So it's a journey, right? You want to start small, you want to see what you get out of it, and then you add it up. And the other thing is that you want to federation helps, right? It really speeds this up because you get to the data only when you need it. So it's not like everything has to be moved somewhere. Just leave it where it is. And if there is relevant data which needs to be pulled because of discovery and federation, the technology will help do that.
Okay, good. Krish, go ahead.
In fact, Eric, to add to that point, there are customers that I have come across who have started with 2 terabytes as the initial data size, but they've landed into the federation space in about 6 months from their start of their journey because they realized that, adding 2 more terabytes and 2 more terabytes and 2 more terabytes eventually brings them back to the same problem of, slowdown and, they again get back to the same issues they faced before they went to the whole, big data platform. So I think that's a very key point that Anjul made that, folks on the call still would need to understand is that the key to success lies in, building blocks and then integrating those blocks in a federated architecture, and that would eventually, get that integrated metadata ecosystem going, thereby giving you the ability to be flexible and scalable in any one of those blocks. So if you look at some of the case studies Anjul outlined, some of the flexibility is achieved because you are compartmentalizing the data into consumable blocks, and then you can actually scale it out.
And one of the attendees has a really good question here, and it kind of allows me to segue into a comment I want to make and a question I'll put forth to you, Anjul. The attendee writes, bottom line, are organizations deploying big data integration platforms seeing secondary follow-on return on their initial investments, since integration is a prerequisite for effective big data management? And that really speaks to something I was trying to articulate at the top of the hour, which is a successful implementation of this kind of platform. Once you reflect as an organization upon your information architecture, how it's coming in, where it's being moved, how it's being transformed, and so forth, it seems to me you will have many more opportunities to refine and really streamline those processes, and guess what, get better value, but also streamline other processes that aren't going to be as necessary anymore and thereby save some money on your infrastructure. Anjul, what do you think about all that?
No, I completely agree. I think, Eric, you kind of answered that. but it's like people, sometimes customers start and they bring in data sources and they have one thing in mind, or they're expecting a certain kind of returns and insights. But, I think the beauty of this whole technology is that it is, once you have the big data platform and once you've identified and brought in these sources inside the enterprise, after that, the creative individuals there will be at play with this data, right? Now there is a new field there, and as they start exploring, what we found is that somebody may start with, again, just one use case, and very quickly they get to 5, 6, 8, 10 use cases. And those are unique. They had not built the platform keeping that in mind. But the good thing is that even though those use cases and those ideas come up, it's not like they have to rebuild the platform.
Right.
Unless, of course, there's obviously they identify that there's another data source that needs to be added here. Mm-hmm. And you can build multiple applications, and different users in the organizations can actually build and leverage this big data. One very interesting phenomena that we are seeing is that how there are obviously with the relational world, we saw it, right? The barriers between the IT and the business side, where the IT set up the platform or the repositories or to manage the data, and the business side had to be dependent and ask the IT that these are the reports that are needed. With big data, those silos are getting broken. Because, once the platform is set up, and that's why, one of the points that I was making during this conversation was the focus on empowering the non-IT user, which then gives them the ability to, once the data has been acquired, of course, IT still has to do that and, build the platform. Then the business users can explore, discover insights, and start really driving what applications are needed, what business processes have to be changed, transformed, or new opportunities that they have never gotten into before, new business opportunities. That is interesting that, some of the telco customers that we've been working with, they came out with so many different products and services which had nothing to do, which you would not think a telco provider should be thinking of.
Yeah. Right.
Yeah, absolutely. Absolutely. I mean, this whole space is creating innovation all over again. I mean, that's the best part of big data, right? I mean, it's spurring innovation back to a large extent amongst different companies, and that is definitely, needed for the state of the economy too.
Yes,
absolutely.
That's why empowering the non-IT user is so key for big data.
Well, and that's a really good segue. Maybe let's go into some of the other aspects here. One of the questions revolves around Vivisimo. One of the attendees writes, Vivisimo used to be a visual search engine, which I used to use. Now is it sort of an IBM umbrella for enterprise search? And is that what you're talking about when you're talking about being able to empower a business user? Because obviously what the business user needs is a very intuitive process, ideally a drag and drop kind of thing, and visual tools to see things. So can you kind of talk about how you're actually empowering these business users?
Yeah. So there are two parts, I guess, Eric, to your question here. Yes, Vivisimo has a product called Velocity, and the Velocity platform has capabilities to discover, federate, and navigate a variety of information sources, right? Help organizations access, understand, and navigate through whether it's structured data, unstructured data. It could be data which is behind the firewall, right, and get more value from it. So it provides that single point of access to many disparate data sources and extract relevant information and without moving the data, right? So that's certainly a key aspect of it. But Vivisimo also has very unique capabilities around being able to make this information consumable for a non-IT user. And this has been sort of some of their new product offerings. So these were new technology developments that have not really, gone to market in a pervasive manner. So that is what we are going to be leveraging to make this more consumable for the non-IT user. So there's the velocity, which is, like you said, for searching across the behind the firewall, but they also have something which is becoming a part of the application framework for these new classes of applications, and you'll see a rollout of our first version of that around the information on demand time frame, which is our conference, yearly conference in Las Vegas. I believe it's October 21st to 25th.
Okay, good. Here's we'll try to go another 5 or 6 minutes to get to as many of these as we can. Here's an awesome question. One of the attendees is referencing the world-renowned data analytics scholar Edward Tufte, and asks, and Krish, feel free to jump on this one too. This is kind of a curveball, I'll admit, but it's a very interesting question, I think, certainly in terms of understanding the context and the methodology for leveraging these kinds of solutions, because let's face it, they do go much broader and deeper and wider, and they're much more multifaceted and complex than traditional sort of data warehousing type issues and traditional BI type analytics. The question is, to what extent are the principles of high resolution and small multiples utilized either in the development of the analytic applications and or in the development of the output of the data? That's a curveball, folks. Anyone? Krish, do you want to touch that
data? Well, I mean, it definitely is. Hold on a minute. Let's look at what the question reads here. To what extent the principle of high resolution and small multiples as promulgated by data analytics scholar utilized either in development of analytic apps and or in the development of out. So the whole idea is that if you look at the whole nuance of what Tufte had actually proposed, analytic models, right? And Anjul actually, in fact, spoke about this. The whole nuance of creating this big analytical model into which you're going to feed that big data, especially if you're looking at building the model in a statistical tool like R, or even SPSS, if you will, with old Clementine, that creates a lot of variables because the amount of data that is needed to create the model is going to be large in volume, but then the data output that is expected from these models are going to be so small in terms of multiples, right? And it's going to be so discrete. So it's going to be like you're going to look at almost pinpointing bullseye and then saying that, okay, I'm going to nail it down, and you'll nail it down. That's the perfection you get when you take a very, very stringent approach to building a model. I mean, that will work in a traditional analytical app. In a big data analytics app or in a big data analytical model, that kind of high resolution or that kind of, if you will, small multiples will never become useful, simply because when you build a model, again, you are going to actually shoot in the dark. you start with a crystal ball to say, yeah, I'm going to touch on customer sentiment, but then suddenly you discover competitive intelligence, or you're going to look after competitive intelligence as a research subject, and you hit analytics, analyst reviews, where Wall Street analysts are giving your organization bad reviews. So it depends on, in terms of, it is a navigation as it comes by. There is no planned route here, right? And hence, the applicability of that kind of stringent measures to big data analytics is right now in its infancy. I mean, I'm not saying it's not possible in the future, but right now where we are speaking today at this point, I think it is in its infancy. I mean, your perspective, Anjul.
So I agree with that, Krish, because when we talk about say the multiples, right? So I'm assuming this is referring to the amount of data, the complexity of data, and obviously in the big data, what we've seen is that the more data that gets analyzed or can be analyzed, your results or answers are going to get more accurate, and you're going to they're going to be much more accurate than if you were doing small amount or a subset of the data, right? Like just as an example, right? Credit card companies, they have been obviously predicting or catching credit card fraud, right, for over 2 decades now. But what is different now with big data, right? Why should they say that, oh, I'm using big data for fraud detection? Well, what is different is that before, if they were able to analyze, say, 30 days of customer transactions and build a fraud detection model which captured or was leveraging that 30 days of customer transaction to test the model, now, like one of our customers is testing that fraud detection model and hence has improved the fraud detection model because they are testing it against 7 years of customer transactional data.
Yep.
Right? Yep. So when you go from 30 days to 7 years, more data, so more accurate answers.
Yeah, no, that's a good one. And folks, let's go ahead. We're not going to be able to get to all these questions. They're awesome, and we'll be sure to pass them along to you, Anjul, and also to you, Krish. But let's close on this one, the glue that holds all this stuff together, metadata, and let's talk about metadata. And what about semantics or ontologies? How do you work in metadata to help make sure that you govern what you're dealing with, and what kind of ontological functionality do we have here?
So from an IBM standpoint, I mean, it would be a longer response, but I think, we are obviously integrating with with our master data management system. I mean, depending on obviously this is again sort of, I would say it's the beginning of the journey. There is a lot that has to be done here. There are, for business-specific domains and for obviously analysis of this text, which, I mean, the industry, the unstructured text that we are analyzing, there is the ontologies, the vocabularies, the industry models that will have to be integrated, right? Industry models which were sort of the starting point as warehouses were being designed. So all of that still pertains and applies to the big data world, and we are starting to do that, say, on the business glossary side. For like the telco industry, for healthcare, but there is clearly more work to be done here by the industry in general.
Yep, absolutely, Anjul. I agree there. I mean, in fact, Eric, the way I would look at this is, metadata by default is going to be the glue, right? I mean, you need something to integrate these two different drastic worlds. The place where I see ontologies play a big role is going to be in visual data discovery. I mean, if you're looking at providing the business users, all the data and say, go discover what you want and come back and tell us what you need to extract. So let us say that there is a data scientist team and there is a business team. The business team would definitely like to apply ontologies and then be able to categorize and classify and be able to parse, all this data and put it into like subject, oriented maps and all those, the cool GUI stuff that you do with ontology and semantics, right? I mean, you could do all that, and then the result set could simply be just extracted from that exercise and pushed into a metadata engine, and then you can create metadata maps, and like how Anjul pointed out, you could go all the way to business glossary if you're on the IBM stack.
Interesting. Okay, good point. Well, folks, we're going to make sure all these questions get passed on. We've gone 80 minutes now, and we try to keep these at least 75, or I should say at most 75. So huge thank you to Krish Krishnan and Anjul Bhambhri for their time today. Yes, we do archive all these presentations. You can check them out at insideanalysis.com. And with that, we're going to wrap up our live broadcast here, folks. Thank you so much for your time and attention. What a great topic. It was record attendance today on the show, so thank you for all of you out there. And presenters, stick around. We'll do a quick post-conference call. And with that, we'll bid you farewell, folks, and we hope to catch up to you in actually 2 weeks. We'll take next week off as we're going to a conference out in San Diego. If you're at the TDWI conference, see if you can look us up, because that's where we will be. All right, folks, thanks again. Take care. Bye-bye.